Welcome everyone. In this tutorial video we see how to use the dynamic crop growth tool in the land support platform. This tool runs at regional scale. In this tutorial we see as an example the Markfeld case study. Markfeld is an agricultural area in Austria. So we have already selected this case study. And let's move here in this toolbox where you can find a long list of tools. We move here CAP Agriculture and Forestry. Okay, we go down Dynamic Crop Growth Modeling. Okay, and we select this Production, Nitrogen Leaching and Soil Organic Carbon Change. Double click and then the model requester pops up. We select the region of interest. We have already drawn a region of interest within this Markfeld area. For instance, let's select this ABC. The starting date of the simulation is the first day of 2012 and the simulation will end up on the last day of the 2018 year. Here you have a long list of possible crop rotations. These crop rotations were identified and simulated according to the common practices that we have observed in the Markfeld area. And for this video, for instance, let's choose this last crop rotation: sunflower, wheat, and maize. This sequence of crops over time. This list of crop rotations include both organic and conventional systems crop rotations. In this case, this sunflower, wheat, and maize rotation is a typical one of the conventional system. So it means that is automatically linked to an inorganic fertilization. So that's why you find just inorganic here. Other rotations are automatically linked to organic fertilization. As you can see here, we have just one level of irrigation, 100. It means that it is a full irrigation, but we can possibly add other options where we irrigate with less water, because the system is really flexible thanks to the dynamic link to the ARMOSA cropping system model. In this first application of the tool, let's choose this conventional tillage. So it means that the model simulates a plowing at 30 centimeter depth in our soil. Let's imagine not to retain crop residues in our soil. And let's select the outputs: nitrogen leaching, production, and soil organic carbon change. Evaluate. Okay, let's press OK. The tool takes time to perform this simulation, and the higher is the number of the soils which are present in the region of interest, the longer the time required for the simulation. And while the system is running, I want to remark that the complexity of the ARMOSA cropping system model allows to simulate a very detailed agricultural system, but this complexity is hidden from the user thanks to this easy to use model requester and the display of the results. So let's have a look at these results. So double click here, then you have this first table of the results. You can open this table. You have the list of the crops and the soil types which are present in the region of interest. In this case we have 1, 2, 3, 4, 5 soil types. And then for each of the soil types and for each of the crop you have the production expressed as tons per hectare, the annual nitrogen leaching, and also the soil organic carbon change expressed as a percentage of change on annual basis. So let's close this table, and we have also a possible maps to display. For instance, we want to have a look at the maize production. So in our region of interest we find the mean annual production of maize in the soil types. Here you also find the values associated with the maize production in each of the soil type, and the legend is present here. It means this light green indicates that we have a production in between 8 and 10 tons per hectare. Okay. And what about the nitrate leaching? The annual nitrate leaching is quite high, is above this 60 kilograms of nitrogen discharged annually in 1 hectare. It means that it is a very high loss. We have a very high loss of nitrogen in this system with this rotation. And what about the annual soil organic carbon change? Okay, we have these light brown results in our soils. It means that generally we have a loss of carbon annually in our system. So a possible solution to increase the soil organic carbon in our soil and at the same time to reduce the nitrate leaching in our system, we can run once again this tool. So here again, CAP Agriculture and Forestry, Dynamic Crop Growth Modeling, Production Nitrogen Leaching, Soil Organic Carbon Change, double click, we select the same region of interest, the same period of time for the simulation. Okay, and we select the same crop rotation but with the addition of a cover crop, in this case a leguminous cover crop. So we keep the same type and sequence of crops but with the addition of cover crop in between each of these crop seasons. Then we select this 100 in irrigation. The fertilization is still an inorganic one. Tillage in this case is minimum tillage because we want also to reduce the soil disturbance with our tillage. So we select this minimum tillage. It means that the ARMOSA cropping system simulates and harrowing instead of plowing. we select to retain residues in the soil, and the outputs are still nitrogen leaching production and soil organic carbon change. Evaluate. Okay. The tool requires the same time required for the previous application. So it is about to end. Okay, everything went fine. So let's double click here. Let's go straight to this nitrogen leaching. Okay, we succeed in strongly reduce this nitrate leaching annually. And what about soil organic carbon? We have also improved, enhanced the soil organic carbon stock in our soils. As you can see here, now we have a quite good stock in our soils. What about the production? For instance, this maize production went down a little bit, but just 1 ton per hectare. So it is an affordable reduction for the system